Hello and welcome. My name is Kareem Iskander, and I'm a developer advocate with DevNet. And we're doing this section in the DevNet Start Now section about introduction to Git. So thanks for joining me, and let's get started. In this session, we're going to look at an introduction about what is Git. We're going to walk you through just a quick overview of Git, and what I'd like to do is I'd like to give you a hands-on portion of the entire workflow on how to get started with Git. So let's do that. Before I get started, this is something that if you're interested in joining the challenge, go scan this QR code or go out to Start Now Challenge and check out the challenge that we've built for you. I'm going to have within this session, I'm going to have a note on the different commands that you might need in order to complete that challenge. So look for the hints, but the idea is what you've learned as part of this track, you're going to apply in order to complete this challenge for a chance to win something. So go to cs.co, Start Now Challenge, or scan that QR code that I have for you and have fun with it. Okay, so why Git? Why do we need Git? So chances are if you're in a team working on code and you're collaborating, you've asked yourself these questions, or how do I make incremental changes and share my work with others? How do I go back to the version of the first file from yesterday, last week, last year even? And, you know, I see my code has changed. What are the differences between version X and version Y? We have a team of 6 people and, you know, you're working on the same file. I want to be able to know who has changed what at one point while we're working together. And so if you've asked yourself that question, Git is what you need. So what is version control in general? Version control is a system that manages changes to set files in order to keep a history of those changes. So think about this: if you come from a data center world and you have VMs, a version control is similar to taking a snapshot from a VM where you configure your VM, you have your operating system, you get your libraries up and running on that VM, you take a snapshot, and then you can go mess around with that VM as long as you want. And if you broke it and you want to go back to the initial snapshot, you can just essentially revert, right? So think of it as that, or an incremental backup of files. Similar to wiki versioning as well. So when you make a mistake, it essentially protects you and protects others, and you can start experimenting. Since you have a backup, you can always go back. So it's a safe place for you to play with code. Okay, so what is Git? Git is an open source distributed version control. It's the protocol that we use in order to leverage GitHub. So let's not confuse the two, and I hear this a lot. Git versus GitHub, right? So Git is the protocol. GitHub is essentially a commercial company. It's a website that hosts all of your Git repositories or your Git or your code. And obviously, from a developer's perspective, there's a lot of emphasis on GitHub because you hear about it a lot, and it was purchased for a lot of money by a big company. So protocol is Git. The website is GitHub. It uses Git in order to accomplish the task, but it's just a hosting company, okay? All right, so version control is not something it's not a new concept that's been introduced. Version control has been around for ages, and we've seen that if you've programmed back in the days, you've seen the CVN or SVN, which is essentially a centralized version control. And what that means is you have a central repository. A repository is just a folder that contains your project code or your libraries or whatever. And that centralized place holds your code. And with CVN, essentially you have one person going out, checking out that code, working on it, and locking that record. No one else could access the code until such time that, as a developer, you go back in and check back in that repository and unlock it. So that record is locked, no one can contribute to it. So you can see how it's a bit, it's not as easy to use CVN. And what happened, the shift that happened is we went from a centralized version control and to a decentralized version control with Git. where the concept is essentially that you go as a main, repo integration manager, create that repository of code and share that with the world, whether that's public or private, whether they're internal developers that you work with or external developers that would contribute to your project. It doesn't make a difference. So you share that project out, you share that repo out, and you are considered the integration manager at this point. Whatever happens to that repository has to go by you, and you have to approve it in order for it to become the new source of truth, right? So you're the integration manager. At this point, anybody can essentially contribute and work on your code. They essentially go out, grab it, clone it, and we're going to look into the different terminologies here next. And I can start coding against it. An entire developer team can start coding against it. It doesn't matter. And then they can contribute to it. So that's what the decentralized, and this is why Git has become so popular, because it allowed huge amount of teams, big teams, to work together and collaborate against a repository without having to worry about overriding each other, without having to worry about breaking the code, because you have the version control. So we can see how powerful that is and why it's becoming so relevant and important in our developer journey. All right, let's look at Git and what you need to know in order to get started with that, okay? So first of all, basic terminologies that you need to understand. Repo or repository is essentially the vault for storing version controlled files. Think of a repository nothing more than a folder that you create, right? That contains all your projects files, your code that you want to keep track, versionize, and whatnot. Working directory is the visible directory and its content. This is where you have everything. Version files are files that you told Git that I want to track. So for instance, could be your Python code, these could be your SDKs that you have within your project, these could be documentation, excuse me, that you've used. It could be any of that. On version files, well, you're going to ask me, if I have project, wouldn't I need to keep track of everything? No, you don't. That's not necessarily true. So the ability to tell Git which ones you want to versionize versus the ones that you don't want to track unversionize, these are allows you to do things like have, for instance, your password files, your authentication methods, your certificates, all of that be part of your project without exposing that and sharing that with the other developers. So if you guys hear about, sites being hacked or companies being hacked, what ends up happening is somebody out there goes and shares the password files in GitHub. And once it's in GitHub, once it's been versionized, you can't get rid of it because you have version control of it. So I can go back, even if you delete the commit or you delete an instance of it, I can go back since day one with being able to have a version control and be able to trace those deleted files. So a lot of times what ends up happening is people end up scrapping and sniffing the GitHub repo for password, the github.com for passwords in order to obtain authentication to some of the projects that are out there. So just be careful with that. If you mess up and you end up sharing some passwords that are not supposed to end up on the internet, the only way you can revert back is to completely delete that working directory at that repo from GitHub and start over, okay? Commit is the action you take to essentially take a snapshot of that version control file. Branches is a safe place for you to work. So you basically get a copy of the repo, the repository, and you create a branch and you work on that branch. And once you're ready to essentially commit those changes to the master branch, to the main branch, you just merge it back in. And what that allows you is allows a team of many developers to work on the same code base without having to override each other, right? And allows you to essentially have merge protection. And then we're going to see that in our hands-on portion. Okay, so the best way to get started, and keep in mind this just a hint, you're going to want to understand this and know the commands for your Start Now challenge. First of all, the best way to get started with Git and learn it is just to memorize those 5, 6 commands. They're nothing major. They make sense, and I'll show you the flow so you would see it. But just know them by heart and use the command line application, the command line, to be able to do all of that. So first of all, setup, right? Git config -- global user.name and user.email. This is a one-time setup that you need to know, that you need to configure once you've set up Git on your local machine. And what this allows us to do is, if you're part of a team, if you do a commit of a code, in the log, when you go Git log, I would know who has done what commit at what point, right? So it identifies you as you're working on the common repository. Clone is basically downloading. So you go out to GitHub, you say git clone, and you get the URL, and that what that does is it creates a working directory on your local machine. Git status will give you information about how long, what the status of the branch that you're working on, or the repository that you're working on. So have you committed? Have you made changes but they haven't been committed? Has it been added to Git as Git tracking or not? So Git is actually going to tell you all of that, so you would know. Then Git checkout -b with a branch name. This does 2 things, right? It goes and it checks out a copy from master to your new branch, and when you supply the -b, it creates a new branch for you, as well as makes a copy of your master into that new branch. You can do this also in 2 steps. You can say git branch and create a branch name, right? That will create a new branch. Then you can say git checkout from master to the branch. Then you would create a branch, and that would make a copy of it. So the easiest, whatever you're more comfortable with, you want to do it in 2 steps, or you just apply the -b property, that would do the exact same thing for you. Once you've done that, now you can start working in the new repository. And what would happen is you start working, git add, the file name will add that file, will tell Git that I'm tracking these files, and I want you to keep them in mind. That just gives visibility for Git that I have changes in this file and I'm adding them, until you do git commit -m, supplying a message in quotation here, that would essentially take a snapshot of your changes to that repository. Okay, so this is hey, I'm making a snapshot. So be mindful of something when you're doing your commit. Supply a message that makes sense, right? So if you're changing code or whatever, say I've changed this print statement to reflect this debug statement or whatever, right? Something that makes sense. So when I go back and I look at the different commits, I can understand what has changed in the code, as opposed to saying I've changed code in line 1. That doesn't tell me much. So just be mindful of that. Git checkout is file name basically checks out a specific file from the master branch or from whatever branch you're on into the new branch. And then if you want to see the other commands that Git supports, git --help or man git, and that will give you all of that information. So you can see how easy it is to just get started. It's like 5 commands, pretty straightforward. And this is the flow that you're going to find yourself doing the majority of time. I know I do it all the time whenever I'm writing code. That I start by cloning a repository. Whenever you're starting off with coding, you don't actually want to start from scratch. There's chances somebody has created something similar on GitHub that you want to either work on or alter. You can bring in libraries that would help you from GitHub. So you don't actually ever have to start from 0 when you're writing. You're getting started with programmability in general. And DevNet has a lot of repositories for you to check out to get started with the specific technology API. So go to developer.cisco.com and check that out, or go to our GitHub repo, github.com/Cisco DevNet. But essentially what you do is you go out to GitHub, you get the clone, and GitHub is going to tell you I have a URL that is in HTTPS if you want to clone, or if you have SSH configured, I also have an SSH URL that you can leverage in order to clone the repository. Once you've done that, you've created a copy of that repo on your local machine into the branch master. You can do 2 things at this point, right? You can go and check out and create a new branch and start coding there. So in this case, we supplied the command git checkout. We went and said the sample code is my code. We made a copy of that code into a new branch called my code, and now I have an exact copy of master. So I can play around with my code within my code branch however much I want. I can break the code. I can change the lines. If I ever break it and where I can't go back, I can just go again and say, hey, go get checkout from master back to that branch, and it's going to tell you, hey, you're merging an old version. Do you want to overwrite your code? And you're going to say yes, and now you have another fresh copy that you can mess around with. So you can see how it kind of protects you because you have a copy in master. So you work in your my code branch. What you do, if you change a line in your Python file, or you've added a new file within the directory, Git is going to tell you, hey, I'm seeing that you've made changes. I'm not tracking them, so you need to add them, right? So we supply the command git add, and what that does, it tells Git that, hey, I have a new file. I'm adding it to be tracked. You need to commit it at this point. If you don't commit it, it hasn't been backed up, or there's no snapshot of it. So go supply the git commit, and what that does is essentially does this workflow for you. So you go, you code. Once you're ready to take a snapshot, you say git add, and once you're done with git add, or you're ready to create you've told Git that it's essentially keeping track of it, you can go out and say commit, and it will take a snapshot. So you can play here for a while throughout your entire development journey until such time that you're ready to push out to share that within the master. Then you can go and say, hey, I'm done with my code changes, my new enhancement, my feature that I've added, my bug fix. I want to merge. So you go say, I'm going to go git merge from my code into master, and that merges and updates the code base. So that's all happening on your local machine. So now, once you've approved those changes, you can go out and commit these changes to GitHub, right? So push these changes to GitHub. So, and this is where the integration manager comes in play. So you go out and say, I've made changes on my local. I want to make the new repository that we're using, or the new code base that we're using, the latest changes that I made. So you go out and say git push, and what that would do is, if you're the integration manager, the owner of this repo, you can just simply push. But if you're not, then what you have to do is you have to open a pull request with the integration manager saying, hey, I've made changes. These are the changes. Approve it or disregard it, but I'm making a pull request into your code. And as an integration manager, as an owner of that repo, I get to decide whether this feature makes sense to be allowed or not. Okay. And then finally, if you want to see what's been happening with my Git throughout the journey of it since day one, you type in git log, and that will give you all the status of all the commits by who at what time since the inception of that repository. So you can see how useful it is and how easy it is to get started with this. So let's go ahead and look at the demo. What I have done here for you is I've created a sample repo under my GitHub. So go out if you want to play with this /kitskander. You can also go to Cisco DevNet repository, where we have a whole bunch of libraries that you can explore and play with. But just to keep it simple, I created a repository, called it, here we go, called DevNet Day. That DevNet Day repo has code.py, and I want to get started with it. I want to start changing it. I want to start, applying patches to it, whatever that I need to do. So I went in here, I started clone. GitHub gives me two options. I can clone from HTTPS or SSH. I don't have SSH configured, so I'm going to copy this link right here. And if you remember, the first thing that we need to do is, so I'm in my home directory here. I'm going to go and say git clone supplied by the URL that I copied from. And that what's going to happen is Git is going to go and bring in a copy. And also did for me is it created a folder, a working directory for me with this name, with the repo name. So if I go in DevNet Day Notice how I'm in that directory, and Git is telling me I'm in this branch master. And if I do Git status at this point, it's telling me there's nothing to commit. Nothing has changed. The directory is clean, right? So let's do ls-al just to look at what's in here. You have your hidden .git file. This is where you have all your trees, your pointers to the different versions, the different commits. This is essentially what's under the hood, right? And if you know, there's a lot more to learn about that. If you want, we have within the Start Now section, you can actually drill into, and we touch on what that tree structure looks like and what does it mean and what are the different files in there. But for the sake of this conversation, let's just go out into code.py here and just change. This is just a Python print statement. It's hello world. I'm going to change that to hello from DevNet day. Okay, so I changed this file. Notice how now I have an X here, which means if I do git status, Git is actually going to tell me, hey, dude, no changes added to commit. You need to add in order to track. This has been modified. I'm not tracking it. So the next logical step would be git add and the code name, the file that I want to add, I want to track. And so this is going to add it to me. Git status at this point, it's telling me that, hey, by the way, this is modified, but it's not committed. There's no snapshot that has been happening. If I do git log here at this point, right, it's telling me that there's only been one commit by me on this date, and this is the comment of it. It's the initial commit. If I quit here and I go git commit -m, this is essentially going to tell me that I'm making a new commit to this repo, and I am supplying the message of updated my print statement from D-Day, okay? And so it told me that one file has changed. I've inserted one line and I've deleted one line because I've edited one line only, right? If I go git status again here, it's telling me it's clean. If you want to start making that changes to reflect, then you can go and say git push, and that's going to change on GitHub. I am the integration manager, so I can actually go say git push, and that's going to push my master from my local machine out to GitHub. And if I go out to Git here and I refresh, notice how now I have two commits. I have my code.py. If I look at my commits, I have the different information. This is what we have just done together. This is my initial commit. And if I go into code.py, it actually has reflected the changes that I've made. Okay, and I can actually go and revert back. So if I go, and this is an important piece. So let's say you broke it and you want to change back. If you do git log, notice how the commit string here, this is the string that you need to supply in order to go to that snapshot. So if I want to go back and revert to this commit, then I can go say git revert, so followed by this commit ID here, and that's going to change my pointer to this initial commit. So you can see how useful and powerful this is to get started. You have a couple of options, right? I'm working in master. If I go git checkout -m and I create new branch, -b, new branch, it's created the new branch for me called new branch. And if I check out here, I have my code.py, right? So you can make changes again here, make changes the nanocode.py. I can hello from new branch. So I'm working in a new branch right now. It's different than my master. Git add code.py, git commit from new branch. Not a proper message here, but I'm running out of time. So here it is. If I go code.py, you see in my new branch, this is my hello statement. If I go git checkout master, now I've moved to the other branch, the master branch. if I do cat code.py, it's a different print statement, right? So what's going to happen is if I'm trying to merge, it's going to give me a merge conflict because I'm merging from a branch that has different code on the same line. So Git is going to tell you, I don't know, dude, what you're trying to merge here. I have a same exact file with the same exact number of lines. Line 1 has this code, this print statement, and line 1 on the other branch has this print statement. You, as a user, you need to figure out what you want me to do with that, right? So it protects you, and you actually have to go and alter and pick which version you want to keep and overwrite, right? So you can see how useful and powerful this is. And this is all I have today. Hopefully this was useful. If you want to get more details about Git and how to get started with it, check out DevNet Start Now section under developer.cisco.com. Go out to our repo in DevNet on GitHub. Look at the libraries that we have for you, and don't forget everything that you learned in the Start Now section here, track. Take the challenge, scan this QR code, you'll apply what we've taught you here, and for a chance to win something. Thank you for joining me, and I appreciate your time. Thanks.